well.
Very, very well. I'll take a few more photos.
Thank you.
If everyone could please take your seats, we'll get started in just a minute. I see a few more people out enjoying those last rays of sunshine. Come on in, take a seat, and we will head into our final sessions of the day. All right, welcome back, everyone. Now, I know you all know as well as I do, if there's one mot qui fâche, as we say in French, or a word that makes everyone crazy when it comes to these kinds of discussions, it's plastics. More than 8 million tons of plastic go into the world's oceans every year. But there are some incredible innovators out there who are committed to tackling this issue, moving from pollution to innovation. Some of these great entrepreneurs are here with us today for our final panel on the plastic issue, co-convened by the Solar Impulse Foundation. Would you please welcome with me now our panelists, Catherine Schuen. Also with us, we have Tato Biggio. Tato, where are you? We have Patrick Casey, Laurent Villemain, and to moderate this session again, let's welcome back Aminda Lee.
Round here. Thank you very much indeed, Jeannie, and hello everyone. I've probably already seen most of you, but for those of you who weren't here this morning, just let me introduce myself. I'm Aminda Lee. Everyone comfortable? I'm Aminda Lee, I'm a journalist, and I specialise in environmental topics, and I'm based in Rome. And it's a real honour to have this final panel of the most incredible day. We've heard some really amazing innovations today, and you're going to be hearing some more now as well. My microphone seems to be going on and off. Is that irritating to everyone? No? Okay, fine. It's just irritating to me, then I can cope with that. Okay, this session is being co-convened by the Solar Impulse Foundation, whose founder, Bernard Picard, will be shortly giving a keynote speech to round off this Ocean Innovation Platform Day. Before then, in the next hour, we're going to be hearing 4 innovative projects to tackle the problem of plastic pollution, not from the point of view of removing it from the ocean, but actually from the point of view of stopping it get there in the first place, which is, I think, a pretty smart solution in itself. We're going to have questions after the speakers, not a lot of time for questions, so if you have something really urgent, make sure that you catch my eye, because we want to make sure that all our timings are correct. And for those of you watching online, welcome, and if you do have any questions, please do send them in. We'll probably have time for maybe one from online. And those of you, I notice we don't have a lot of social media tweeters in the room. I've not seen much going on Twitter, but in case anyone gets inspired at the end of the day, the hashtag we'd like you to use is MOW, so it's Monaco Ocean Week 2022. That's quite easy to remember. Now, we all know about the plastic problem in the oceans, and we're all familiar with the projects to remove the plastic. And today we're going to look at how we actually stop it getting there in the first place. The projects that we're going to showcase are part of those more than 1,000 clean and profitable solutions to address the environmental crisis identified by Solar Impulse Foundation that we actually heard about, and we saw a winner earlier on in the previous session. So this panel, I'm not going to again give long biogs because I want to really hear from the people themselves. So we have next to me, I have Catherine Schuen, who is founder and CEO of Wasser 3.0. Then next to her, we have Tato Biggio, who is co-founder and co-CEO of UBQ Materials. And then we have Patrick Casey, who is a financials operation manager at Arclight. And last but not least, we have Laurent Villemont, who is co-founder of Local 3 and Replace. So I'm going to have a little chat with them all, and then we can go to your questions after that. So I'm going to start with a very wide approach, and then we're going to start to get narrower and narrower as we go through our speakers. And who I'm going to start with is, I'm going to start with you, Tato. Because you're from UBQ Materials. Can you tell us what your company does and how long it's been operating? Just give us some background on it.
Does it work? Yeah. UBQ has developed a remarkable tool technology that enables us to take household waste, the entire streams of material that compose our household waste, and convert all of them into one material. And that material has thermoplastic properties. So in a way, we have created a new plastic that never existed before, or a new material that never existed before, being the outcome of converting all the waste streams that typically will end up in landfill. So what is the difference between UBQ and other technologies? Typically, when you talk about alternative plastics or thermoplastics, you will be seeing companies that are recycling or combining plastics. You will be seeing companies that are recycling paper and cardboard differently, and then metals and minerals. There's no company yet that is taking the whole thing, meaning the food residues, the mixed cardboard and paper, and the diapers, and the mixed plastics, those that are recyclable and non-recyclable, all of them together, without the need of separation, before they end up in a landfill, and converting all of them, again, together into one material that is homogeneous and that is consistent and can be used in the existing industry to replace conventional plastic resins that are made out of oil. So that is the solution of UBQ, and what we basically end up doing is saving all these valuable materials that are regrettably called waste because nobody knows what to do with them into a new natural resource that comes back to the economy to replace pollutant and energy-intense materials like conventional plastics. That is UBQ.
I mean, the thing that I find remarkable is that I mean, I've never heard of anyone putting it all together and then turning. Why did you decide to take that approach?
Well, if you think about it, if you see waste, household waste, you will find that about 80 to 85% is not plastics. It's food residues, it's some carton trimmings, a lot of cardboard, a lot of paper, some diapers, depending on the country. And plastics, mixed plastics, which are about 15%, as I said. So the problem is bigger than that slice, okay? And all those materials that end up in landfills or are incinerated in some places will slip into oceans or into rivers or into lakes because nature does what it does. And there are floods and things move from one place to the other. So the problem is bigger than the plastics, okay? It's 100%. And not too many people know, but when organic matter goes into a landfill, okay, it decomposes anaerobically and it creates methane. Methane is a gas that is 84 times more powerful than CO2. So landfills today are one of the biggest pollutants of the environment. And people don't know it because we all feel, okay, landfills are like the cemetery of materials, they stink, there are floods of landfills and underwater leaching. You don't see the gases of landfills. But landfills are responsible for about 10% of emissions. So by saving all these materials getting into landfill, the 100%, we are saving the methane, we're saving the materials, we're creating a circular solution that is viable and sustainable.
Now, you've kind of sort of answered part of the question that I want to ask you now, but why did you decide to tackle the ocean pollution, plastic pollution problem from this point of view?
Exactly. Look, there are amazing companies trying to clean the environment and the ocean, but the true problem is that it's like you are in a shower and with a towel you are trying to dry yourself. You have to close the shower. So, so in a way we are that company that is trying to close the shiver, right? And to avoid that, so that then other companies can do the beautiful things they are doing. And by the way, helping all these amazing entrepreneurs and companies enjoy the ocean, okay, for the marvelous ideas that we're presenting today. We're coming from outside the ocean to protect the ocean, and that is the aim of UBQ. And I thought that maybe it will be interesting for you to see what we're doing visually. This is a tray of McDonald's, actually McDonald's, okay, who is a very polluting company. They and us as consumers, of course, of McDonald's products. This tray is made with UBQ material. It looks like plastic, and this is not plastic. This is chicken bones, banana peels, hamburger leftovers, the pizza with the box, with the oregano and the mozzarella, everything in it.
And the diapers.
And the diapers. And the good thing is that because companies now want to, in a way, present themselves are more conscious and more ecological, they ask us if they can stamp our name next to the McDonald's. So we have here UBQ, which is a great thing, by the way, because in a way the world is really trying to support this kind of technologies to be part of the change. And we need rapid change if we want to get to, in the next 10 years to save the planet, as we'll say.
That's actually quite remarkable that you're allowed to put your name on that.
But they asked. We didn't ask. It's from them. Right?
Okay. Right. This seems very enlightened in a way. In a good way, good publicity for you, nice and free. And so that's one of the kinds of things you're making. What kind of other stuff do you do?
So basically, we do the material, okay? We will supply the material to the industry. Companies that are working with us that are known are, for example, AB InBev, the beer company, Mainetti, who is the biggest fashion retail packaging company in the world, Pepsi. PepsiCo is doing crates and showrooms, everything with UBQ. Maybe the most, for me, the most, the pearl in in the group is Mercedes-Benz. Mercedes-Benz is now doing 26 different car parts with UBQ. It's quite remarkable, really, because the auto industry is tremendously difficult to penetrate. You need to have a very strong product, a very strong validation, all the certifications. Your value chain has to be clean and perfect. So being part of the value chain of Mercedes is unique. And this has opened up enormous frontiers for UBQ. Those are the companies you know, but then there are the companies that you less know, which are the manufacturers, the compounders, and the resin suppliers that are starting to integrate UBQ. And UBQ is one solution. We need many more because the plastic problem, the waste problem is 2 billion tons of household waste. 2 billion tons is the weight of 10 million jumbo jets full of people. 10 million jumbo jets full of people every year. 8 million tons of that, 400 will go to the ocean, regrettably, right? But the problem is huge. So as we were saying with the KEL, there is enormous potential for many other companies to come into the space, and we obviously will welcome. And by the way, I personally will give any advice to anyone who is thinking about it on the long way we went through, 10 years developing this technology, and the place where today I believe many of you would really like to be, and I will be glad to help in any way.
And in fact, we're going to be hearing some more solutions because not everybody has taken the same approach that you have. But just before I start talking to the other panelists, I believe that you're setting up something in the Netherlands. Could you just tell us a little bit about that?
Yeah, very briefly. We developed this technology in Israel, in the south of Israel, actually in the desert. We wanted to also create some employment in that area. When we succeeded in completing the development, we started looking at the best ecosystem we can find, and the north part of Europe was decided to be the right place to begin. So we're building now a plant. Actually, the plant is built. We're hopefully going to operate it at the end of this year. We're going to be supplying 80,000 tons of UBQ material made with Belgium, German, and Netherlands waste, okay? The idea would be then to expand the company and to create UBQ material in different countries with their own waste. So basically it's closing the loop of waste and materials in every country to have Argentinian UBQ, Singapore UBQ, et cetera, et cetera. That's the aim of the company.
And of course, you don't want to be shipping waste around the,
Exactly.
the world.
Exactly,
Yeah.
exactly.
Okay. Thank you. Absolutely fascinating. Now we're going to, I said we'd start broad, and we're going to start going a little bit narrower with our next speaker. Has got a slightly more selective approach to stop plastic getting into the ocean. Patrick Casey from ArcLight, been getting to grips with another tricky problem, which is non-recyclable plastics. We've also touched on those a little bit before. So, Patrick, can you tell us what your company does and what makes it stand out?
Yeah, absolutely. So ArcLight, its entire vision is to take unrecyclable plastic waste and convert it into materials for the built environment. So what we've done is taken stuff just like this, which under traditional and current infrastructure, is completely unrecyclable. It's typically made up of multiple resin types, and it's very complicated to separate and put into different streams. So what ArcLight does is take it all, mix it, and we develop aggregates. So we have a few different sizes. We have a small size, which is great for concrete, and a larger size, which is great for drainage projects. It can be even used in gardening and hydroponics. And so essentially what we've done over the past 7 years has developed it from a kitchen concept all the way to a large-scale facility in Southern California. The core concept being taking local waste and providing that to local industry. Unfortunately, or fortunately, we've developed a commodity, and the commodity has a lot of applications. So we can service many different markets. So think construction, infrastructure, roadways, precast concrete, lightweight concrete, all the way to drainage filler, to hydroponics, to a wide assortment of projects. And it's really endless because at the end of the day, if you're using mineral gravel, expanded clay, expanded shale as your normal substrate or filler, you can use our product either as a full or partial replacement. And with that, every ton that we produce at the facility is 1 ton less going to landfills. And stuff that I showed you here is ripped off of brand new, unpackaged or unused, rolls. I didn't want to bring the material from material recycling facilities to post-consumer waste that we have in our facility. I don't think that would travel so well, but at the end of the day, we're taking plastic waste and giving it new life. And our first focus was single-use plastics, primarily because that's the one that goes immediately to landfills. But we can process everything from nylon fishing nets all the way to pieces of plastic that were collected on beaches. The only thing we don't touch is PVC, but I think many of my colleagues here will share that there's a rational reason for that.
Can you tell me how long did it take you to get to this stage? Because again, it's interesting to hear how long the business takes to start up.
So it, like I stated, we started 7 years ago. So it started in 2015, and it has taken a significant amount of development, R&D, workshopping ideas, building out a prototype. And in 2018, we launched a prototype facility, which has a capability of doing 150 tons per month in Argentina. And then launching it, in 2020, we launched a large-scale facility, which can do up to 1,500 tons a month. So it has been a very long journey. A lot of blood, sweat, and tears poured into it. Working with plastics isn't always the easiest. They don't like to bond together. They don't like to work together. So you're constantly working recipes, working the material to get the end result. And at the end of the day, we have plenty of plastic available for everybody here on the panel, and many more innovations to to come part of and tackle.
Now, your company made a conscious decision not to create a new polymer or a new kind of plastic. Why did you decide to go down that route?
It's a great question. We really wanted to focus on the built environment, mainly in terms of scalability. So the company was first designed for concrete. If you think about concrete, it's one of the most largely used materials in the world. It's practically everything's built from it. And for that, if we can replace aggregate even at a small percentage of base, you're taking a massive impact. So we didn't think it was necessary to go down trying to make a new polymer or homogeneous blend that would, compete with other virgin plastics. It's far too complicated. We built a simple rock that, is smarter than dumb rocks at the end of the day.
Now, you mentioned hydroponics a couple of times. The people who don't quite know what that is, can you say what it is and how your product is used for that?
Yeah, absolutely. So hydroponics is essentially indoor farming. You'll have large trays set up with typically either water or some type of cultivation, and there's a growing medium that the roots adhere to. So our product is a full replacement for expanded clay and expanded shale, which are, for the most part, are pretty standard industry options. The issue with those options that they are, environmentally really, really bad. And individuals working with the material, they typically have to clean it before they install it, and they have to work it so many times, and that at the end of the crop, they throw everything out. With our product, it's from the bag right into the tray. You can wash it with a hydroperoxide, some enzyme wash, and you can reinstall it. So you can reuse it over and over again, which is key in creating the full circularity. And especially with hydroponics, you're growing plants, either food or in California, it's cannabis. And those two angles are pretty phenomenal if you're having the right control, and using our product as a growing medium is perfect for it. And we kind of fell into that. Some person called us up one day in Argentina, was like, can I use this in hydroponics? And we're like, yeah, sure, you should give it a shot. Let us know how it goes. And it's kind of expanded from there.
That's great. Very, very interesting. The thing that sort of strikes me is the fact that it's reusable, recyclable. And once the I'm sure at some point it has to be replaced. But is that material then, can you recycle that and then turn it into other things or more rocks?
So if we're just looking at our footprint, we've designed our entire production line to be circular in nature. If we have a product at the end that doesn't fit our desire, we just toss it right back in the machine. If someone has the product and they want to recycle it, they just drive it right back to our facility, or we'll set up an arrangement to pick it up and then simply rinse and repeat. So as we scale, the solution then becomes more viable across the regions that we deploy in. So for right now, we're in Argentina, we're in the US. We plan on expanding and growing our business through licensing and also cell phone facilities. So if we're looking at the long-term picture here, as we scale, so does the solution to the problem. If there's a facility nearby, it can process it. And the issue is, unfortunately, current infrastructure, as many of here will attest to, it doesn't have the capability. It's great at collecting, but what do we do once we collect it? That's the next hurdle in the problem that we need to solve.
Okay, and you were talking about expansion plans in the US. Can you just give us a little bit more details about that?
I can. For right now, we are focused on strictly getting up our SoCal operation plant completely up and line running. So we've done that over the past 2 years. We're growing the market in the Southern California region, and we're kind of seeing where the demand takes us. Most likely, the next facility will be in the Northeast, and then we'll start positioning them around. We do have a licensing opportunity that will go out to Paris for CMEX in the next couple of years. So that's something that's been interested, and licensing will probably be the biggest expansion part of our strategy, working with these players because they already have, significant stake in the communities that they're in, and it helps companies like us, which are more experts in the plastics and generating and transforming it versus trying to do the full workup.
Okay, thank you. So we're now going to move even narrower, kind of, with Laurent Villemin, who knows firsthand all about complex packaging. In fact, very complex packaging, because he was once at a firm and worked for many years in making complex packaging for makeup, which has various particular challenges. So you know all about complex packaging, and now you are the founder of 2 companies, one called Local 3 and one called Replace. So can you tell me what those companies do and what you do with the complex packaging?
Thank you. And as my colleagues explaining how it's complex, effectively, to sorting the plastic, etc. We effectively follow the same approach, saying if you start to sort, if you start to clean, if you start to put a lot of complex operation, it will create a lot of impact of carbon, it will create a lot of cost, and at the end, we'll have a product, but nobody will buy it. So the point was how we can effectively solve this global issue means that transform directly this complex packaging with no operations before, directly on the product which can be sold at a very low price where we can compete existing over product. This is for Replace, where we patented a process with our partner ISA, which is a machine maker, effectively to create something really new in terms of this possibility to transform the plastic. And the local cube is to complete the approach. We say, if you want to have a very impacting footprint in terms of life cycle analysis, we have to do everything locally. So catch the plastic locally, transform it locally, and identify market where you can sell locally the product. So means today what we are already succeed to do. So we have the first plant located in Champagne, in France, where we mix a lot of different plastics. So it will be after a quiz to give you how to identify the different plastics. So what we are doing differently is that we mix everything. So we don't separate it. We take everything, we mix on one step, and directly we produce. I just take the small one because the small one is the only one I can put in my bag and not to be stopped at some areas.
I hope it wasn't in your hand luggage. That could be a bit of a...
And for example, in this product, for example, we have headdresses of champagne bottle, which are coming from the activities, transformed directly on one step on this stamp, which is used in the champagne industry. for the posting.
Talk about a circular model.
Yes, exactly. And in this case, with this product, first we are able to reach the current price of existing other product. First, second, the workers are effectively happy with this because sustainability. In this case, the worst things becomes a quality, and we can use it without gloves or other protection because it's the quality is very high. And what we have measured too, which is quite surprising in the result, is that when we compare the life cycle analysis of this product versus the equivalent in wood, it's 4 to 5 times less because you do this everything locally. So we consider that the both together are one of the solutions, because as you said, it's a so large topic that every new ideas and development will help. So imagine a world where we will have a small plant of replace everywhere in close to the beach, and when immediately the plastic will be transformed on useful product with endless product. So means it will have a value. So nobody will put in the sea. You will keep it to do something good.
It's just very inspiring. All of this is just incredibly inspiring. Now, the other thing that is very interesting about your company is the machine that does this. Can you tell us why this machine is so special?
Alors, it's so special because first we identify how we can do what I just show you, and we identify several ways to do it, and we test it. I will not show you the first pictures of the first test. As you say, it was wow, very strange. And very, very quickly, when we consider that we have this good approach, we contacted the company ISA, where I worked in the past when I was in the packaging industry, to say, okay, now we have a principle, how we can transform it on a very industrial machine, where we can work 7 days a week, 24 hours a day, with a very sustainable approach and a very competitive approach. And I gave some input. First, just electricity, nothing more as energy, no water, nothing, just electricity. A size which allow to have a competitive and economical potential, but not so big, because I don't want to be above a certain level of electricity, for example. I don't want to enter in the complexity to declare the activity, etc., where we know how it can be complex in some countries, and where we can spread everywhere in the world. And last point, it was the machine has to be enough intelligent to adapt the setup, whatever the product we put inside. And this will allow to have a low competencies people, because you know how it's difficult to have a good people on the plants today, especially when you want to run 7 days a week. It's much more than complex. And where we can effectively be sure that wherever you will put the line, you will be able to manage it. And voilà. So this, we build this, and to succeed in this approach, it was effectively to simply put the different product inside, and to use the polluant as additive to accelerate the process. And so now with this approach, which is somewhere a molding approach, but quite different, we are able to have a cost of production which is, I will say, for this type of items, 4 to 5 times less expensive than whatever other technology in plastic. But it will be not very technical pieces, of course, because otherwise I will be not here. But with this type of product, effectively, we are able to reach this level of productivity. And believe me, to reach the level of price we can have with other material, it's open massive market.
And you've got quite a, I mean, you touched on the social approach that you have. Because this machine is so easy to use, the machine does all the work, and so it's very simple to use. You're able to open up job markets for people with disabilities. That's already happening in France.
Exactly what we have done is that in order to be sure and to show to everybody that it works, we did an agreement with a company which hire disabled people, and all the workers working on the line are coming from this company. And after just, I will say, 5 days of training, they are able to manage fully the line. Bon, sometimes they call me the knight, okay, but globally it works.
Okay, well, that's again, and we're hearing multiple win solutions here, and that's like incredibly exciting, I must say. And there's one more thing that you're aiming to do, which is not just help companies be carbon neutral, but be plastic neutral.
Effectively, so the point is that following the tendency of the carbon neutral is to say, imagine a world where wherever you have a plant, an industry, which put on the market plastic, and if we stick just close to them a replace plant or one of your plants, where we can transform and fix the same amount of plastic coming from the collectivity and the industry, to say, okay, on this area, we are able to show that, okay, we sell plastic on the world, but at the same time, we stick and we transform the equivalent of very complex waste on the real useful product.
Okay, well, I think there'll be a lot of business for that in coming up. So definitely something, an opportunity there, a business opportunity. Thank you. We're going to have time for questions after we've heard from our last speakers. So if you do have some, get them at the ready, also because we don't have a lot of time, so we want to come to them quickly. Now we're going to zoom in right to the microplastics level. Now, we all have heard about microplastics, and we've heard how terrible they are and how they, basically what they are they're categorized as small pieces of degraded plastic, less than 5 millimeters, more or less, and they can travel thousands of miles into the open sea, and depending on their degradation, they remain at various steps in the ocean. And it's the plastic we don't see, and it's the plastic that ends up on our plate and ends up in our bodies. We've all heard that we eat half a credit card's worth of plastic every year. And this is where you come in to help us stop doing that. This is Catherine Schoen, founder and CEO of Wasser 3.0. For those of you who don't speak German, I think it's pretty obvious, but we're talking about water here. And I'd like you to tell us a little bit about your company, what it is, how did you start it, and why?
First of all, thank you very much for the invitation. Thanks a lot for all the great panelists before. Now we're talking about the unseen. So the microplastic pollution is the unseen pollution where microplastics are released into the environment. And I'm the founder and CEO of Wasser 3.0, and we tackle this problem with a vision: waters without microplastics and micropollutants. This means that we have detection methods, removal technologies, and circular economy approach to tackle the pollution scenarios in our waters, and not the pollution scenarios in our oceans. We start at the very first beginning. So when microplastics are released into the environment, in industries, and in wastewater treatment plants, because if we stop the pollution there, it will not be there. So the ocean pollution will be decreased. And what we do at Wasser 3.0 is quite simple. We make the unseen seen. With a simple technology, clump and skim. So we clump microplastic particles, no matter which polymer type, no matter of size. So we talk about size smaller than 5 millimeters, as Amanda said before. And we clump them together using a secret chemical compound, more or less like this, because this is silicium dioxide, and our compound is based on hybrid silica gel, so silicium dioxide is part of this compound. And we use this hybrid silica gel, which clumps the particles together. And what we need from the technology side is only a reactor with a stirrer, and nothing more. So the water comes into the reactor, the stirrer turns on, a vortex is formed. This means localization of the particles, and then we add the hybrid silica gel. and then the magic happens. The clump and skim technology brings the larger agglomerates on the surface. They're popped up like popcorn and can be easily skimmed off. Turns out waters without microplastics, turns out waters without micropollutants, because this agglomerates can also absorb the micropollutants, and with a significant choice of hybrid silica geles, it's not just an adsorption, it's a fixation reaction, and finally you get what everybody wants: clean water.
Okay, so a very interesting technology, and thank you for explaining that. Your company, I mean, it doesn't just do that, because you start, I mean, you've got to detect it first, and then you've got to remove it. And then, of course, what happens after that with the material that you found?
So first of all, the detection is absolutely necessary, because if you know the amount of pollutants in your water, you can tailor your technologies. And if you can tailor, you can scale, you can grow, you can adapt to various scenarios. This is one major point where we start with the detection of microplastics, because then we have a process control system. The removal, you already know how it functions, brings up the agglomerates. The agglomerates are silicon and carbon-based materials, and these particles, 2 millimeters up to 2.0 centimeters, so larger agglomerates, they are reused. So then we are coming into this area of panelists, because then we're talking about the seen plastic agglomeration pollutions, and we can reuse our materials in subsequent steps. So for concrete, so as a filler, for road construction, and in the next step, we want to try to build some B2B products that everybody knows how microplastic removal can save not only the water quality, but being in a sustainable circular economy structure.
So I can imagine, if we're talking about microplastics, you need an awful lot of these to be able to produce something that... so how much do you have to collect?
This depends. I mean, everybody knows that most of the industries use polymers to produce, manufacture, and recycle the plastic. So there are lots of polymers in the surrounding, and this stop the pollution at this point means that you do not need that much time to collect the microplastics, because there's enough in the process. And if you use the process water and bring the microplastics out of this water, then you have larger amounts, and then it becomes more and more impactful.
And you're currently working on a project in Germany. Can you tell us a little bit about that and how far you've got with it?
So we are currently running a continuous operation in paper industry. This is our first continuous operation plant where we directly attack on the process water, and the other large project is a long-term study at the wastewater treatment plant, because we already know that at the wastewater treatment plants all the pollutants are at one time and one place, and there it makes sense to stop the pollution as well.
Now, the unique thing, or one of the unique things about your company, is that it has an eco-social model. Can you explain what that means?
So we are, from the bottom of our heart, a non-profit company, which means that we have a hybrid capital model. So for most of the investors now, the eyes are closed, and this is not relevant for us. But this hybrid capital model brings independency and transparency, and this is what is most important when you talk about microplastics, which is not regulated and where you do not have laws, because then you create the impact by setting the solutions. And the hybrid capital model means that we invest our profits directly to 100% in research and development, education and awareness raising. And this is very important, because it's a really, really complex issue, and going through all this in deep and wide, so digging deeper and having the widescreen takes lots of time. And I'm a former polymer chemist, so I come from the evil side. Some people say it's the evil side. I don't think so, but you have to know lots of things about polymers to set up a solution which is sustainable and makes sense in the end. And where the industries and the wastewater treatment plants, people want to start doing something without regulations and laws. And that's the point. So bringing everything together, bringing a solution on the market without these points, without regulations, laws, means doing something completely different. And this is why we choose the hybrid capital model in a non-profit company structure, because this makes for us most sense, because we act for planet and people first. And this is our way we want to follow the overall mission.
But of course, doesn't this put investors off because they want profits?
No, we are completely open for investors, but they have to go a slightly different way, like the discussion on return on invests and exit strategy, because we do work now for the future of our planet, and this needs a little bit longer timeline for return on invest, and return on investment could also be cleaner water, beating water scarcity, and so on and so on. So there are lots of other topics where we generate return on invest, not only on the economic side.
Okay, that's good to know. Now, what are your plans for expansion?
So we are going with the industries, the early adopters, who really want to change their processes. Because what we see is that not only microplastics is a driver, sustainability processing is the driver. So if we, and this is what we do in the paper industry, if we set up completely new process design, sustainable process design, by reusing the water, saving energy, saving costs, by reducing the waste with a circular economy approach, and by removing microplastics, we have the crown on, because then the process has a return on invest for the company who set up the solution, because they have a little invest, they have less operational costs, and finally, and then some, they get something out on the SDG side and the ESG side.
Another kind of win-win solution. Okay, well, thank you. In fact, it's been really interesting to see all the panelists' faces as they're watching the others, going, "Wow, that's amazing!" It's really interesting, because you're all in similar fields but doing such different things. Really, really interesting. So now it's time for your questions. We have about 5 minutes. We have one over here. If we could. Oh, thank you, Jeannie.
Thank you. Very interesting. I'm curious if any of your solutions can handle disregarded or lost fishing gear, things that are sort of traditionally hard to recycle and dirty to clean. I'm wondering if your innovative solutions can tackle that big challenge.
The answer is yes. The issue a lot of times with this fishing gear, or say like a shipping line, is that it's typically thicker in gauge, so you need certain machinery. Now, once that machinery is procured, absolutely we can, like our system can process nylon netting, fishing netteries, everything up and down the chain.
Thank you.
And I will add, it will be a good material.
Okay, there's a question right at the back there. Right at the back. Thank you. It was a little bit hard to see you. Thank you for waving so much.
Thank you. I'm wondering if we'll take into cognizance that sometimes, even if we take care of our own immediate environment, things can be shipped from elsewhere. I'm from Lagos in Nigeria. It's a coastal city of about 20 million people. And I can tell you plastic is a major pollution. And my question is,